There it is. Okay. So we just did what? What was the chapter we just came off of, or the lesson? Pythagorean theorem, correct? So Pythagorean theorem can only be used with what? Right triangles, okay? Not any triangle, but just right triangles. So we got a little bit specific with right triangles. We talked about the Pythagorean triple. Give me one of the, not one of the special right triangles we're going to do now, but give me one of those Pythagorean triples. What's the smallest, easiest Pythagorean triple? 3, 4, 5, okay? Goes right in a row, 3, 4, 5. That's a Pythagorean triple. So we did learn something a little bit special about right triangles, but now we're going to do a lot more, okay? There's, I think, 2. Yeah, there's 2 that we're going to do specifically, all right? So two special right triangles. So I'm going to give you the first one. I don't know. It depends how fast we go today. I don't know. Did I have it down as a part A or B for homeworks? Okay. All right. So I don't know if we'll have, yeah, we got 20 minutes. We should be able to do both of these. We'll see. I'll talk fast. You listen fast, okay? So this side right here is equal to this side. So this is an isosceles triangle. All right, I mean, that's nice. But what I want to do is I want to deal with the angles inside of here. So just giving you this information and nothing else, you should be able to tell me what this angle is and what this angle is. So think about it and tell me. What is it? What? I'm asking you for this angle and this angle right here. Okay, that's true. They do have to add up to 90. And they're both what? They both have to equal each other because these two sides are equal, right? So the opposite angles must be equal. So if these two add up to 90 and they're both exactly the same, it's 45. Very good. So this, I'll tell you what, I'll take these little arcs out of there. So each of these, let's do it in red, would be 45 degrees. So that's our first special triangle. And we call it, all right, it's not much of a stretch, not much imagination given to this, but that's okay. It says exactly what it is. It's a 45, 45, 90 triangle. And we don't have to say right triangle because we already got the 90 in there, okay? Some people might say 45, 45 right triangle, but I usually say 45, 45, 90 triangle. Everybody with me? All right. Let's do this. Let's say that was 1, and this was 1. Now I wanted to find the hypotenuse, which we'll call C. Everybody with me? So let's solve for C. Everybody ready? Okay, follow along. So C squared equals what? I got numbers here. So 1 squared plus, I got a number there too, right? So I'm not using A and B because I got numbers for A and B. Everybody good so far? All right, it's not too hard. So C squared equals, what's 1 squared? 1 plus 1 squared is 1. What's 1 plus 1? 2. Your parents ever ask you, what'd you learn in school today? What can you tell them?
1 plus 1 is 2.
Yeah, that's right. So I learned what 1 plus 1 was. Okay, 1 plus 1. And you literally did, right? 1 plus 1 is 2. All right, of course, we learned a little more than that, but you could always say we learned 1 plus 1. Then they'll probably call the office and I'll get fired because I'm not teaching you enough stuff. All right, not really. So what do we do here? I want to get C by itself. I want to solve for C. So what do I do? Take the square root. What's going to happen if I take the square root? That's going to cancel, but I also have to do what? Take the square to the other side. So C is equal to what? The square root of 2. That's a number that you should know. You should memorize. Okay, we're going to use that number quite a bit. All right? So watch. The hypotenuse, I'll write it right here, which was C, is equal to the square root of 2 times either one of these legs. Right? If it's a 45, 45, both the legs are exactly the same, aren't they? So this right here, that right there, super important. okay, with this type of triangle. So this works with any 45, 45, 90 triangle, even if these aren't 1. Okay, what if, come up with a side. What's a side length? Don't give me anything super crazy. 4? Okay. If that's 4 and that's 4, right? What I want to do, without going through all this mess right here, I could do that, but instead of putting 1s, I'm putting what? Putting 4s, right? I could do that, but I kind of came up with a little system that the hypotenuse is always going to be the square root of 2 times one of the legs. So I should just be able to look at this and say, oh, the hypotenuse, or C, right, is equal to the square root of 2 times what? 4. Now, we don't really write it like that. That's a little awkward to write it like that. So what are we going to say? We'll put C equals, what's a better way to write these two things multiplied? I can't multiply them together. I can't go 4 times 2 is 8. Can't do that because that's a square root of 2, and this is a whole number 4. So what's a better way to write it? 4 square root of 2. Very good. So we write 4 square root of 2. Now, some teachers say 4 root 2. That's okay. But there are other roots. Okay, there's cube root, 4th root, 5th root. And so some teachers, just to make it a little shorter, just say 4 root 2. I don't know. I've always said 4 times the square root of 2. You got to say a little bit extra, but to me, I like that better. All right, so what is C? How do I say that? 4 times the square root of 2. Or you could just say 4 square root of 2. That's fine. All right. If you really wanted to, you could say 4 root 2. It's fine. Other teachers do. It doesn't matter. All right. So what if, let's just do one more. Let's not even write it down. Let's just do it in our head. Let's say that's 7. What's C? Just in your head, really quick. What is it? 2 square root of 2? When this was 1, what was C? It was 1 times the square root of 2. When this was 4, it was what? 4 times the square root of 2. If it's 7, then it's going to be what? 7 times the square root of 2. It's as easy as that. Make sense? All right. Let's try another one. Same thing. I just want you to think a little bit. What if this was, 27, and this was 27? What is C? It's just 27 times the square root of 2. Make sense? All right. It's not always going to be quite that easy. They may give you this. All right. They might give you this. Say square root of 5. Okay. Just making up a number. And they ask for the legs. Let's call it X. So if this is X, what's this going to be? Has to be X, because if it's a 45, 45, these two have to be the same. Agreed? So now this is a little different. So watch. Actually, let's make this a different number. Let's make this an 8. Okay? So what would this be equal to? Well, let's go back to our little box right there. It says the hypotenuse is square root of 2 times one of the legs. So let's plug that in. So what is the hypotenuse in this situation? Square root of 8 equals what? Square root of 2 times what? In this situation, it's X, isn't it? Do you agree? What's that? I told you this was the square root of 8. I don't know what this is. I don't know what this is. See, I'm giving you, I don't know what this is. See, before, I gave you the legs and you had to find the hypotenuse. This time, I give you the hypotenuse and you got to find one of the legs. It's always, this is the square root of 2 times one of the legs. Okay, so that's what I'm writing. Watch. So this, the hypotenuse, right? Remember, the hypotenuse is what? the square root of 2 times one of the legs. So I'm filling stuff in now. I know the hypotenuse this time. Okay, this time's different than the other time. All right, so this time I tell you what the square root of 8, or the hypotenuse is. It's the square root of 8 equals what? The square root of 2 times one of the legs. What are my legs in this situation? X. So what do I have to do? I got to solve for x, don't I? So look what I have. I just have a simple little algebra problem. Square root of 2 times x. So how do I get rid of that square root of 2? I can't hear you. Everybody's whispering. Either my hearing's getting bad or you guys aren't talking very loud. Square it? I mean, that's an option, but I'd have to square everything. Then I'm going to have an x squared. Then I'm going to have to take the square root again. So watch this. What if I had 8 equals 2x? You automatically can look at this and you know exactly what to do. What do I do here? Divide by, okay, let's come back to this. Yes, because square root of 2 is just a number, all right? Don't let the square root of 2 like mess you up. Like, oh, square roots, I hate square roots. No, it's just a number like anything else is. So that number is being multiplied by x, okay? So how do I get rid of something that's being multiplied? I what? I divide, just like I did over here, right? I would divide by 2 here, wouldn't I? If it didn't have a square root, yeah, same thing. So what do I do over here? Divide by square root of 2. What happens? Square root of 2's cancel, so x is equal to, look what I have. I got a square root on the top and bottom, so you could go like this. You could go square root of 8 over 2, right? So what is that? That's the square root of 4, which is what? Just 2. You see that? So what's x equal to? It's just a 2. Well, that doesn't make sense. That's not square root of 2 times this. But is it? It is. Because, look, what if I knew the bottom was 2? What would the hypotenuse be? It'd be what? 2 square root of 2. That's not the same as 8. Is it? It is. Let's simplify the square root of 8. Let's do it in a different color. I got too much red going on here. Look, square root of 8. Let's break it down. What times what? What times what's 8? Come on, talk to me. Help me out. Okay, 4 times 2. You could go 8 times 1, but that's not going to help you simplify it. So 4 times 2. Agreed? So what can we do here? What's the square root of 4? It's 2. What's this? Would you agree the square root of 8 is the exact same thing as 2 square root of 2? Would you agree that that and that are the same? Yes. Okay. So that's kind of weird, wasn't it? Yeah. But really, it wasn't anything difficult. Like, the only difficult thing is to divide by the square root of 2, right? And you get 8, the square root of 8 divided by the square root of 2. You just got to simplify that a little bit. You could have done it another way. You could have taken the 8 and simplified that. We already did it once. What is square root of 8? It's 2 square root of 2 over what? Square root of 2. These cancel, and you're left with 2, just like we were over here. So there's a couple ways you could approach that. I just did it the way that I thought you might see it best, okay, the easiest. All right? You guys look very confused. I don't know what else to tell you. Let's do an example from the book. Let's do that. It's kind of what we just did, but I make the triangle look just a little bit different. So let's go here. Let's go here. Let's go here. All right, so this is a right triangle. There's my right angle. These two should be equal. It doesn't quite look equal. We'll pretend it is. Is that all right? So if this is 45 degrees, and this is 45 degrees, and they tell you this is 3, we'll call this C, we'll call this B. Yeah. Okay? And I want to find B and C. That's what I want to do. Well, there's one that's super, super easy. What's the easiest one to find here? B or C? Why? You're whispering. I can't hardly hear anything. It's equal, right? It's equal to 3. All right, so B is equal to 3. It's funny, my CP classes I had, I kept on telling them, be quiet, be quiet, be quiet. Now I'm telling you guys, speak up, speak up, speak up. Big difference. And they're both geometry classes. All right, anyway. So that was easy, right? Because if it's 45, 45, what's true about these two sides? They got to be equal. All right, so if this is 3, that's 3. No biggie. C is now, okay, that we learn this little, not trick, but this little relationship between, the leg and the hypotenuse on a 45, 45, 90 triangle. Now this is almost just as easy. So what is it? You really can just do it in your head. 3 what? Is it 2 the? It's not 2 the. It's 3 square root of 2. Or you could say 3 times the square root of 2. It's not 2 the anything. It's what it sounded like you were saying. I wasn't sure. But that's what it would be right there. 3 square root of 2. Simple, right? The part where it gets a little difficult is what? When they tell you, I'll tell you what, let's do this. Let's pretend we didn't know what those two sides were, okay? And they told you this. A lot of people freak out on this. We'll call this A, and we'll call this one B. And I ask you to solve for A and B, and this is what I give you. So I tell you the length of this is 3 square root of 2, all right? And you got to find A and B. So remember what our little formula was? Hypotenuse is equal to what? Square root of 2 times what? One of the legs. All right? Agreed? All right, you got to know that. I don't think we're going to be able to get to the next one until tomorrow, but that's okay. So we'll do this. We'll split it up. It's good. Have a little breather in between. So what do they give you here? In this problem right here, they tell you the what? Hypotenuse. They tell you the hypotenuse. That's the hypotenuse. So what do I do? Put it right here. 3 square root of 2. And then fill in the rest of it. Equals what? Square root of 2 times one of the legs. Which leg do you want to find? Doesn't matter which one, right? Because they're both exactly the same. You want to call it A? Let's do it A. Now, what do we do to get A by itself? Divide it by square root of 2. Look what happens. Divided by square root of 2, that cancels. What's A? It's 3. See? They cancel. So a lot of people freak out when they give you a square root. But actually, when they give you something that has a square root of 2 right there, it makes it even easier to find the leg because the square root of 2's cancel out. You see that? It gets a little more difficult when they give it to you as a whole number. Let's put a nice whole number in there. Give me an even number. Just make it easy. 16? Okay, 16. So, what if I asked you to find the legs, A and B, if that was 16? So, what's your step? You could just go 16 divided by square root of 2, couldn't you? Because look, how do I find the leg? How do I get the leg by itself? Leg would equal what? You don't have to memorize this part, but I'm just going to show you. If I want to get the leg by itself, what do? No, forget the 16. Just this right here, just that, okay? How do I get leg by itself? You got it. Divided by the square root of 2, right? So what's the leg equal to then? Hypotenuse, what? Divided by the square root of 2. You see, if you know the leg, how do you find the hypotenuse? You multiply it by the square root of 2. What if they give you the hypotenuse? How do you find the leg? You do the opposite, which is divide by the square root of 2, all right? So what's A equal to then? It's equal to the hypotenuse, which is 16, divided by what? The square root of 2. Can you go 16 divided by 2 is 8? Can you do that in this problem? Can you divide 16 and 2? No, because this 2 is inside a square root. It's not just a 2, right? It's actually a number. It's 1.414 blah, 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 right? So you can't just divide like this. Now, some teachers debate on if you can keep your answer like this or if you have to change it. I'm going to show you, because a lot of teachers, I just watched a video the other day. Remember the hypotenuse guy, the hippopotamus guy? All right, it was that guy. He's like, I don't know what's with teachers. I don't know why you can't just keep that square root down here on the denominator. And I kind of agree with him, but I've also heard other teachers, Mr. Rao, I even asked him when he was here, and he gave a good explanation. I forget what the explanation was, but he explained why you should not have square roots or any root in the denominator. So math teachers say, everybody listening? Okay, math teachers say you should not have a square root in the denominator. They look at this and they say this is not simplified. Why? Because why? Because there's a what? Square root in the denominator. Okay, teachers say that. I don't really know why. I've heard reasons, pro and con, but many teachers are going to make you change this. Okay, so you might as well learn it now. Would you agree? So let's do it. So watch. It's called rationalizing the denominator. All right, that's what they call this thing, rationalizing the denominator. And this is what we're going to do. I want to get rid of that square root of 2 in the denominator. So what I'm going to do, time's running out, so I'm going to do this quickly. So what I'm going to do is multiply by square root of 2. Does that get rid of the square root of 2? It does. What's the square root of 2 times square root of 2? It's the square root of 4. What's the square root of 4? It's just a plain old number 2. Okay? So can I get rid of it by doing that? Yeah, but I also have to do that to the top as well. Because look at the red. What is that? What's the square root of 2 over square root of 2? What's this stuff? What's anything over itself? It's a 1. So I'm allowed to multiply anything by 1, can't I? So let's continue. Watch. So what do I have? Don't pack up. Why are we packing up? We should be learning. Watch. 16 times the square root of 2 over what? 2. One more step. What can we do now? Now can I go 16 divided by 2? Yeah, because this is a regular 2. So 2 goes into 2 once, into 16, 8 times. So A would be what? 8 times the square root of 2. That's the way that they want you to write your exact answer. Okay? We still have more to do. Here's what I'm going to ask you to do. Whatever the homework was, what did I say it was? 1 to 16. Now, I don't have the book in front of me, but here's what I want you to do. Just do the problems that deal with 45, 45, 90 triangles. What we're going to do tomorrow is this. Watch. 30, 60, 90 triangles, okay? So if you see any 30, 60, 90s in here, don't worry about it. Don't do them. Just do the ones that are 45, 45, 90. I'm not sure exactly which ones, okay, in 1 to 16 are these. I don't know if all of them or half of them or what, but just do the ones that deal with 45, 45, 90 triangles. Okay.